Quick quiz. If you squeeze a sealed syringe to half its volume, what happens to the pressure? Does it go down by half, stay the same, double, or drop to zero? Lock in your answer. We'll reveal it soon. In this video, you'll see what gas particles do, how their collisions create pressure, what Boyle's law reveals, and how the ideal gas law connects pressure, volume, temperature, and moles. At the particle level, gas molecules move freely and constantly hit the walls. Each tiny collision adds up to create pressure. More hits per second mean greater pressure on the container. Pressure is the force divided by the area it acts on. We measure it in pascals, newtons per square meter. The same push on a smaller area makes a higher pressure. Let's try a quick example. A gas pushes on the wall with a force of 1,200 newtons across 0.6 square meters. Pressure equals force divided by area. That's 2,000 pascals, or about 2 kilopascals. Don't confuse force with pressure. Force is the total push. Pressure is that push per unit area. That's why a stiletto can dent a floor while a sneaker can't. The same force over a smaller area makes greater pressure. Here's a quick checkpoint. Pressure comes from particles colliding with the walls. It is measured as force over area, and it requires consistent units. Want to turn those milestones into mastery? Tap the link to access the practice test, flashcards, and study guide, then jump right back into the video. Lock in what you learned and keep going. Now, Boyle's law. At constant temperature and a fixed amount of gas, pressure varies inversely with volume. When you squeeze the gas into a smaller space, collisions with the walls become more frequent and the pressure rises. Time to reveal the answer to our quiz. When the volume is cut in half at constant temperature, the pressure doubles. That's Boyle's law in action. The product of pressure and volume stays constant. To connect it all, we use the ideal gas law. Pressure times volume equals moles, times the gas constant times temperature in Kelvin. The gas constant is about 8.314 kilopascal liter per mole Kelvin. Always use Kelvin, not degrees Celsius. 3 quick reminders. Always convert Celsius to Kelvin by adding 273.15. Use R units that match your pressure and volume. And remember, the ideal gas law is an approximation. Real gases deviate most at high pressure or very low temperature. Let's apply the ideal gas law to find volume. You have 0.85 mole of gas at 298 Kelvin and a pressure of 101 kilopascals. Using R equals 8.314. Volume equals nRT over P, about 20.9 liters. Here's your gas law recipe. Note what's constant. Switch temperature to Kelvin, match R units, and solve carefully. Let's recap. Pressure comes from countless particle collisions. When volume shrinks, those collisions happen more often, so pressure rises. The ideal gas law, PV equals nRT, ties pressure, volume, temperature, and moles together. Just keep your units consistent and always use temperature in Kelvin. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet content made just for you.